We're going to see the third cranial nerve. The oculomotor nerve emerges from the interpeduncular fossa. This is the fossa that is between the cerebral peduncles around the midbrain. We will talk specifically about the nucleus of the third cranial nerve in specifically the anatomy of each part of the brainstem. Here we're just going to talk more about the function and structure of the third cranial nerve. There are parasympathetic nucleus in which the third cranial nerve would be a preganglionic neuron. That is, we have a nucleus, then a preganglionic neuron, talking about parasympathetic pathway, the ganglion, and the postganglionic neuron. Here, the preganglionic neuron is the oculomotor nerve or the third cranial nerve. This is an example, the reflex in Edinger-Westphal, and in Edinger-Westphal nucleus, here we have the nucleus. Now, before talking specifically about the innervation, we will come back to this. First, the oculomotor nerve has this is the nerve. Inside is the motor function, and outside is the parasympathetic fibers. So the nerve, if we do a cross section, in the middle are going fibers that are going to move skeletal muscle, and in the periphery is the parasympathetic, and the parasympathetic sometimes will contract muscle. So let's see. Between the things that motor fibers in the third cranial nerve innervates are the ocular muscles, the inferior rectus, the superior rectus, the adductor muscle, or rectus internus, and the inferior oblique. This is moved only by the muscle fibers that are, the nerve fibers that are on the middle. Parasympathetic, and also the ocular palpebrae superioris muscle, the one that opens the eyes. And in the parasympathetic pathway, we have, for example, the fibers that go to the constrictor sphincter of the pupil for the reflex of Edinger-Westphal. Alright, so let's review quickly the Edinger-Westphal nucleus and the pupillary reflex. We have the eyes. We put light on one eye, then it is perceived by the lateral retina. This goes to the pretectal nucleus, ipsilateral pretectal nucleus, then to the Edinger-Westphal nucleus in the midbrain, then the oculomotor nerve. So we were in this nucleus. The Edinger-Westphal nucleus is where the bodies of the preganglionic neuron is. This is the preganglionic neuron, and this is the third oculomotor nerve that goes to the ganglion. The ganglion is the ciliary ganglion, and from the ganglion, then the postganglionic neuron is the one that innervates the pupillary sphincter constrictor muscle, and then there is meiosis. So we have the direct and the consensual reflex. So problems that compresses the oculomotor nerve will compress first the parasympathetic pathway or fibers, and then the fibers that are going to innervate skeletal muscle. So parasympathetic fibers are compressed first. The examples are aneurysm or uncalernation. Here, the patient will present with oculomotor nerve deficit, but first with the parasympathetic. So the patient can move the eye exactly as well with the inferior rectus, etc. But what could not do would be the pupillary reflex. For example, the pupillary reflex would be affected in the ipsilateral, well, in the ipsilateral eye, or well, actually, look, we put light. Let's say that this oculomotor nerve is being compressed. So we put light on this eye through the optic nerve, pretectal nucleus, Edinger-Westphal, and here cannot go to this eye. So we will see that there is no constriction of the pupil. Then we put light on this eye, the same. When goes to the pretectal nucleus, then Edinger-Westphal nucleus, and we cannot do constriction of this eye. Now, if there is a ischemia of the oculomotor nerve, for example in diabetes mellitus, because here the vasa nervorum goes from outside to inside, then these fibers are going to suffer first, and so the patient is going to present with deficit on the motor of the or movement of the eye. So these muscles are not being innervated, and so the patient is going to present with a pupil that is down and outward, because the abducent nerve innervates the lateral rectus that now has no opposition with the middle rectus or internal rectus, and the trochlear nerve is innervating the superior oblique muscle that produces the inferior view of the, or that the pupil being inferior or the ocular globe be looking inferior. So if we damage the skeletal fibers of the ocular nerve, we will see the classical pupil or globe looking outward and downward, like if the patient were seeing a dog, for example. And parasympathetic nerve damage will present with defect on the pupillary reflex, but be careful, these are not Marcos-Graham pupils. This is just in the eye that there is damage of the oculomotor nerve. There will be no constriction of that eye, no matter in which eye we put the light.